final project presentation, I will continue introduce about the construction and the development of 5G system in China. First, let's look at what is 5G. In telecommunication, 5G is fifth generation technology standard for cellular networks. Like its predecessor, 5G networks are cellular networks in which the service area is divided into small geographic area called cells. All 5G wireless devices are in cell are connected to the internet and telephone network by radio wave through a local antenna in the cell. The main advantage of the new networks is that they will have greater bandwidth, giving higher download speeds, eventually up to 10 gigabits per second. Due to the increased bandwidth, it is expected that the new networks will not just serve cell phones like existing cellular networks, but also be used as generally internet service provider for laptop and desktop computers, competing with the existing ISPs such as cable internet, and will also make it possible for new applications in Internet of Things and machine-to-machine areas. So why 5G is needed? The spectrum used for mobile communication is becoming congested. Current networks cannot always meet consumer demands for the data. During periods of heavy use, consumers may experience slow speeds, unstable connection, delays, and loss of service. So industry and the consumer will rely on 5G networks to power the device and transmit the data that drive their daily activities. They will need two networks that can provide constant connections, minimal lag times, and increased bandwidth to access the shared data, and the ability to quickly compile to and compute data. In the health area sector, 5G could enable services such as remote patient monitoring, consultation, and even remote surgeon. In transportation, 5G will be the backbone that automobile vehicle rely on. A 2017 study from the Deloitte estimate self-driving car enabled by wireless connection could reduce emission by 40 to 90%, travel time by nearly 40%, and delay by 20%. Okay, here are two graphs that can show the 5G construction that bring a lot of change to China and in economies and many other areas. So we can see that there are and China government policy publish a lot of policy that promote construction of 5G technology. In 2013, the 13th 5-year plan stated that 5G will be achieved by 2020. And in 2017, the Chinese government report mentioned that 5G communication technology to accelerate the development, and the transportation of 5G technology, the national science and technology project and some national plan also point out that the promotion of technology research and development to meet the global unified standards. This picture, we can see that Chinese economies slowed down in recent years, but the development of 5G brings more opportunities to the economy. The Chinese Technology Department predicts that from 2020 to 2030, the scale of 5G commercial-driven consumer consumption will exceed 8 trillion yuan, directly driving total economies up to 10.6 trillion yuan. According to the market forecast, by 2035, 5G communication system will create 12.3 trillion US dollar of output for for global economies in multiple industries, accounting for 4.6% of global actually output in 2013-5. And the manufacturing will account for all of the 5G creation. The largest share of economy activity achieves approximately 3.4 US dollar trillion in the output, account for 28% of total 5G output. So if the global economy grows at an average annual rate at 2.9%, 5G will contribute 2.2 of the growth. So from the 2020 to 2030, 5G's contribution to the global real GDP will be equivalent to the India volume, the seventh largest economy in the world. So why China needs 5G engineering? So 5G engineering has a deep integration of new generations of information technology and economy society, which lead a new round of scientific and technological revolution and industrial transformation in the world. In one word, 5G system is a complex system. Okay, I will introduce the current process of construction and plan 5G system in China. As of the end of February 2020, 80% of 5G network construction in China was implemented as planned, and the number of China Mobile's 5G base station has exceeded 800, and the number of 5G package users has reached 10 million. China Telecom and China Unicom have opened 5G co-construction and sharing in 31 provinces across the country and have officially commercial 5G in more than 50 countries across the country, 50 cities across the country. Okay, 5G system engineering also have a lot of benefits on society because 5G will promote the development of unmanned driving in big data, and 5G will help to rapid use of smart home field, and also 5G will promote the construction of smart city. However, also okay, let's skip this part and introduce in the last part. Okay, this part I will introduce about the engineering development. Okay, first I will introduce a beautiful formula: C equals to lambda V, and C is the speed of light in the vacuum, and lambda is the wavelength, and V is the frequency of light. And as we know, all communications technologies so far are based on this simple and magical mathematical formula. There are only two types of communication. There are only two types of communication technology: wired communication and wireless communication. Information and data are either transmitted in the air or in kind. So it is very easy to transmit data on wired media through at a high speed. In laboratory, the maximum speed of a single optical fiber can reach 22 bits, which is which is very fast than the traditional one. But the air transmission is has a backneck of the mobile communication. Therefore, the focus on 5G is study to the bottleneck breakthrough in wireless parts. Both radio waves and light waves belong to electronic waves, and the frequency resource of electronic waves are limited. According to different frequency characters, they have different uses. We currently mainly use electric waves for communication. Of course, light wave communication is also on rise, such as visible light communication Wi-Fi. Okay, this chart will show the use of ratio waves of different frequency. Uh, let through this chart we through this information we can see that according to the band wave above. So for a long time, we mainly use LF to UHF to communication with mobile phone. So for example, the frequently mentioned GSM 900 and CEMA 800 actually means the network frequency band of 90 MHz and 18 MHz. The currently mainstream 4G LTE belongs to UHF and from UHF. Uh, this picture shows that because the higher frequency, the faster the speed. So So, and I will introduce another feature of 5G millimeter wave. So since the highest frequency is so good, so why didn't we use high frequency before? Because distant features of electronic waves, the higher frequency and the closer to the straight line propagation. Moreover, the higher frequency, the greater the attention during propagation. It is if 5G use high frequency band, then it is the biggest problem is that the coverage capacity will greatly reduce. So covering the same area, the number of base stations will greatly exceed than 4Gs. So in this career, in this condition, so there is another technology called MIMO. It's a multiple input and multiple output, which means multiple antennas for transmission and multiple antennas for reception. MIMO has already existed in the LET area, and 5G continues to flourishing and become the enhanced version of MIMO. This is a picture we can see. This is a traditional base station for 5G and before, and for LTE. And this is a new station for 5G communication, which use MIMO technology. Another advanced development of 5G system is that conditional to the traditional base station. The new 5G station will save a lot of energy. That is beam forming. So the antenna area is arranged on the base station. Through the control of phase of the ratio frequency signal, the lobes of the electronic waves after interaction become very narrow and point to the mobile phone it provides and can change the direction according to the movement of the mobile phone. This special multiplexing technology has changed from omnidirectional signal covering to precise directional service without the interface between beings provides more communication linked in the same space and greatly improve the service capacity for base station. Okay, let's see this picture is talk about the D2D communication mode. This is the last advanced feature I will focus because in the current communication network, even if two people dial each other's face to face, they have to rely on the base station, including control signal and data packets. So in 5G area, if two users are under the same base station communication each other, their data will no longer forward through the base station, and because they can directly from the mobile phone to another one. So in this way, a large amount of air resources are saved, and the pressure on the base station is also reduced. Okay, this part I will introduce about the engineering design. Um, there are basically three technologies. SBA refers to server-space architecture, and it is based on the cloud-native architecture design, and drove to the microservice concept in the IT field. To this end, the industry has proposed design principle based on native. The mission of cloud native is to change how the world builds so far. It is mainly composed of microservice architecture. DEP develops and agile infrastructure represented by containers. The goal is to achieve a flexibility, repeatability, and reliability of delivery. Oh, sorry. Microservice refer to splitting uh, mo- mono is splitting service into multiple microservices with smaller energy. The microservice interact through APIs, and each microservice is deployed ungraded and expanded independently of other service, which can be used without affecting consumer use. Update the application you can use frequently. Based on this design concept, traditional network elements are first converted to network functions, and the network functions is decomposed into multiple network function service. Uh, the SBA equals to network function service plus net service-based interface. The network function can be composed of multiple module network function service and display its function through the service-based interface. So the network function service can be used flexibility by authorized network functions. Among them, NRF supports network function service registration, status monitoring, and to realize automatically management selections and scalabilities of network function service. The second is a CUPS, which refers to control and user plan separation. That is, the purpose of get rid of centralization of the network user plan function, so it is can be flexibility deployed in the core network or in access network, and ultimately achieve distributed deployment. In fact, the core network has been involved among the direction and the separation of the control plane and the user plane. For example, starting from the R7, the control plane and the user plane are separated through the directional technology, and a directly user plane terminal is established between 3G RNC and GGSN, and the user plane data traffic is directly transmitted between RNC and GGSN bypass SGSN, and R8 pure signal nodes such as NME appeared. In 5G area, this spectrum trend is more thought through and more necessary. One of the major reasons is that meet the KPI of milestone latency in 5G network. The optimal fiber propagation speed is 200 km per second, but the data needs to be transmitted back and forth between the terminal and the core network that are more than a few hundred kilometers apart. Obviously, the 5G millisecond delay cannot be met. Therefore, content syncing and distributed deployment are required, except the network side, to make it closer to users, reducing deploying the network backup load. The third one is network slicing. 5G service are 5G work servers are diversified, including Internet of Vehicles, large-scale Internet of Things, industrial automation, telemedical, VR or AR, and so on. So these services have different requirements for the network. For example, Industry automation requires low latency and high reliability, but low data low data rate requirement. HD video does not require ultra low latency but require ultra high speed. Some large scale Internet of Things does not require switching. Parts of the mobility management is the waste of signals and so on. So for this reason, 5G needs to meet differential network service. Therefore, it is necessary to cut the network into multiple virtual and isolated sub-networks to deal with different services. Of course, such as flexibility slicing work can be undertaken by traditionally large-scale backbox device. Naturally, virtualization, softwareization, and further fine-grained modularization of network function can be achieved to achieve flexibility assembly of business applications. And after that, there are a lot of benefits of 5G network that in integration and evaluation. The first one is 5G plus intelligent manufacturing. The 5G networks, wireless connection, high speed, and low latency capacity will be introduced by companies user into small scale application scenarios in smart factories to achieve human-computer interaction and collaborate control, such as smart production, remote control, and product promotion. With the increasing demands for network of production equipment and products, in order to simplify network management and ensure the consistency of business experience, enterprise user will directly lease 5G network from operators to support the information management of the entire supply chain and achieve a unified management of a network efficient and low-cost management of product life cycle. The second one is 5G plus smart energy. Energy companies represented by power companies have strong rigid needs in terms of network coverage, ultra-low latency, and ultra-high reliability and security, and 5G network slicing technology is just capable of meeting the needs of power industry. Based on this, a smart graded application based on network slicing has been produced, which promotes the development of power companies in a direction that contributes to a more reliable and efficient global energy strategy. The node with communication requirement is the power system include various power generation facilities, transmission and distribution lines, substation, power plants, consumer meters, and dispatch centers, making full use of high density features, ultra high bandwidth, ultra low latency, high security isolation, and the scalability of 5G network slicing. Four major application scenarios of smart grids can be realized. One is power distribution automation, the other is advanced metering, and the third is intelligent inspection. The fourth is precise load control. The third one is smart plus 5G plus smart medical. The further innovation and upgrading of wireless communication technology in 5G area has greatly improved the network data processing capabilities and provided strong technology support for the popularization of smart medical care. Scenario-based application of smart medical system based on the 5G network will be quickly promoted, included various medical scenarios such as remote diagnosis, remote consultation, remote surgeon, wearable medical prevention and monitoring, clinical medical monitoring and asset management, and will show large-scale growth. The last one is 5G plus Internet of Vehicles. The Internet vehicle system use technologies such as vehicle-to-vehicle communication, vehicle-to-person communication, vehicle-to-vehicle communication, and vehicle-to-the-network communication, as well as automatically driving and big data analysis to realize a perceptual interconnection between vehicles, pigeons, and road infractions. It is expected that by 2025, all new cars will have networking capabilities, and the global cars networking market will total more than 830 billion US dollar. The Internet of Vehicles and Internet and intelligent driving can reduce traffic congestion by 60%, increase the traffic capacity of road network by 2 to 3 times, improve traffic conditions, release manpower, and increase social production efficiency. Okay, this part I will introduce the post-development stage. The first one is the 5G mobile. So, since the officially commercial use at the end of October 2019, China mobile phone industry has shown a thriving. According to the latest data released by according to the latest data, a total of 35 5G mobile phones were listed in the domestic mobile phone market in 2019. In 2019, the shipment of 5G phone in the domestic mobile phone market was about 14 million, and which of the monthly shipment in December was about 4 million, accounting for nearly 40% of the annual shipment. It can be predicted that the moment of 5G mobile phone scale has been reviewed. According to the data released by the Push Big Beta in December last year, Huawei domestic 5G mobile phone market share at about 72%. Okay, let's look at the global data. According to the data report recently reduced by the well-known market, global smartphone shipment in May were about 82 million units. Among them, Samsung mobile phone market will share about 20.6% of the market, and Huawei has reached 19.7%. Okay, the next part I will talk about some challenge that 5G will bring to us. The development of 5G face challenges in spectral efficiency and system capacity, cost control, and operation. In order to apply technology more comprehensively, it is necessary to expand the application of 5G, such as the Internet of Things. Moreover, low cost, low power consumption, and high stability will become important indicators for application in various industries. Undoubtedly, these trends and evolution will bring serious challenge to the development of 5G terminal technology and directly affect the population of entire communication technology and industry scale. But it's also a real opportunity. Deploying 5G will not be easy, and there are a lot of promising potential CSPs that may give the way to deal the following five challenges. The first one is building complex and dense networks. Because 5G networks will be significantly more complex than the current networks. One component of this increasing complexity is the need for denser networks. New 5G antenna and RNA hardware, although powerful, covering significantly less space compared with existing 4G microcells. This means similar coverage require more 5G hardware and supporting software, a number that multiple features as traffic moves indoors. The second one is keeping operation and maintenance costs low. Adding the necessary hardware required for 5G networks can significantly increase the operating expense. Of course, these costs go beyond the hardware itself. Networks must be configured, tested, managed, and regularly updated, all things that exponentially increase expense. The third one is to meeting low latency requirements. 5G networks require ultra-low deterministic latency to properly function, which while not as critical for telecom application, it is needed for an emerging market of devices that can not only allow a single millisecond delay for one-way communication across the entire infrastructures. Latency networks simply cannot handle this speed and volume of data. Okay, the last part I will talk about the summary and lesson I learned. During the process of the development and learned lesson in this project, I learned many knowledge and useful things about system engineering. Due to the experience about engineering design, I know that project will fail without suitable plan and method. Although technology and knowledge are basic of a system, the correct result still needs to be tested into practice. Besides that, I learned that engineering needs integrated, considered process of system design first because ordered and integrated process is a basis for design a complex system. It is no doubt that a good communication can greatly improve efficiency when I exchange my idea with my classmates. Good communication can reduce a lot of time consumption, even if you have a different opinion compared to others. In addition, how to make a system or project more marketable and economical is another pressure experience I learned when I did much research for this project, which teach me that a perfect system not only dom, dom, demonstrate by all of the required functions, but also it must satisfy requirement of economy, environment, and other characteristics. Thank you.